to more application of GPS, right? And that is in the environment and in the agriculture, right? So in the environment, we have seen like if you want to track some rare animal, right? Then you can do it, right? So you can use in the to track the some wildlife animal. Okay, right? So that we have seen. Then we can also use GPS to uh, map the forest fire, right? Then do some oil spill, right? The movement of and the spread of the oil spill in the sea, right? We can use the GPS in the buoys, right? Which we have installed or we have placed inside the sea. Then we can also like anticipate the earthquake, right? We can get the information related to earthquake. In that also we will use the GPS. Uh, then definitely we will do the forecast, right? For that also we can use the GPS. And in the ocean, like we can observe the effect of ocean tides, right? Using the GPS tidal tracking sites. So these are the application related to environment. Then in the agriculture, we can like the farmer can use GPS based application, right, to do the uh, farm planning, farm mapping, the soil sampling, tractor guidance, crops scouting, variable rate application, and yield mapping. So these are the some latest technology in the agriculture, right? So in that we can use GPS. And farmer can also work during the low visibility condition such as rain, dust, fog, and the darkness. Then the space GPS will use for you can say guidance system for crewed vehicle, right? Uh, they will do the management, tracking, and control the communication satellite constellation to monitor the Earth from space, right? And there are some benefit which is because of GPS, right? So this all we have seen. Then we have seen the augmented system. So augmented system is nothing but the we can say like addition to the GPS. Some more functionality, some more features will add to the GPS, right? And that is because it's you want to use the GPS for some particular application, right? So according to your requirement, you will add some additional system to GPS, and that is known as the augmented system. So we have seen some augmented system, right? Uh, so the list is you can see, right? So these all augmented system we have seen for India. I have tell you about the Gagan, right? So Gagan is a kind of augmented system, right? Which is used GPS. It's kind of a GPS, but it has some more features, right? All we have seen, right? So these some of these augmented system or we can say like most of the augmented system is like they can work with the other kind of augmented system. So they have the interoperability feature, right? So this all we have seen. The first one is vast wide area augmented system, right? uh, this this is developed by, we can say, like or operated by the Federal Aviation Administration station, right? And it's a kind of a space based augmented system, right? SBAS, and its main application is for aviation, right? So generally it's primarily used by the aviation users, and the purpose is for positioning, navigation, and timing. And then the core is continuous operating reference stations. Um, so this is used like for economic organization, contributes the data uh, to this system, and this we can use like for reference, kind of a reference model, right? So in the research also we can use it. uh, Global differential GPS, right? So this is developed by NASA Jet Propulsion Laboratory, right? So it's kind of GPS, but it's support, it's addition to the GPS. They will add some new feature, right? So the application is like real time positioning, timing, and determination of requirement of NASA science mission, right? So it's specifically, more specifically, they will use NASA. They will use this augmented system, or we can say GPS. Uh, so some other system like TDRSS, right? Tracking and data relay satellite system, and this TDRS augmented service satellite, right? So this is also these two are the same, and this is also the future plan of NASA, we can say, right? And in that they will use this global differential international GNS service, which is known as IGS, right? So uh, so it's a kind of international network, right? In that some 80 countries, and from those 80 countries, 200 organization, and from those 2000.
Some students are waiting in lobby.
Yeah, yeah. So it's kind of international organization, right? That some 350 GPS monitoring station of 200 organization from different 18 countries contribute their data, we can say, right? uh, and the mission is to provide the highest quality data, right? And the NDGPS nationwide differential GPS system, right? So it was a ground-based augmented system that provide increased accuracy and integrity of GPS information to users on the US waterway, right? So it's specifically used for like marine in the water. Then these are not the only augmented system, right? Apart from these systems, also some other augmented systems are available, right? So this augmented system is sometimes developed by the government, somewhere it's developed by some company, right? For their use. Then we have seen the GPS modernization, right? So modernization means the upgradation in the GPS technology, right? So in that we have seen like a feature called selective availability, right? So it's because of that the GPS the accuracy was GPS is degraded, right? And that was like 100 meters error, right? If you use the GPS with the selective availability feature, right, then uh, the GPS will show the error of 100 meter, right? So whatever location shown by GPS is actually far from the 100 meter. from the actual location. So that feature is already degraded, right? So in 2007, right? So government announced GPS 3, which was built without this feature, right? And before that, in some 90s, they have that feature, but they have deactivated. So such kind of modernization is uh, uh, happening in GPS, right? Every day. Then we have seen some GPS performance. So the performance is kind of like some they have make some standard. So the GPS or augmented system, they should perform, they should reach that level, right? Uh, so in that we have seen the SPS, then WAS performance standard, and PPS, and the GPS civil monitoring performance specification, right? In that we have seen like in SPS we have seen like the first one that standard was given in some 1913, sorry, 1993, right? So it was released on 1993. Then after some year interval, right, they have upgraded those performance. So the latest one was given in April 2020, right? So now right now the fifth edition is in the effect, right? So then this was performance standard specifically for that was augmented system, right? So that was initialized in some 2008, and currently the same standard are effective. And the PPS, GPS precision positioning service, so that is also uh, released on in 2007 February, and the same standard are active, right, or working. And this specifically this PPS, right? It's generally it's also known as a like military GPS service, right? So it's mainly application in the military field. Then civil monitoring performance. So it's from its name, like it's for civilian use, right? So whatever the GPS we are using, so that for that the latest standard, right? The document was released on August 2020, right? And the same standard, same specification nowadays are in the effect. Uh, so then next is the history of GPS, right? So definitely we are interested in the like GPS technology. Till now we have discussed about the future of GPS, or what are the application of GPS, or what are the technology in GPS, right? But it is also fascinating to see the GPS history, right? How or from where the GPS was started, or from where the GPS the scientists will get the idea of GPS, right? So initially, if you talk, then initially GPS was started uh, to develop a system in the military application, and that is for missile guidance system, right? And so starting from that, nowadays we know like GPS is became the integral part of our regular day by day life, right? Every day, almost every day, we are using GPS for navigation. So we'll see that history. So uh, that that we can say like it was started in October 1957, right? So uh, on that day, the 4th October, right? On that day, the Soviet Union, means Russia, have launched their satellite called Sputnik 1, right? So And when they launched that satellite, after that we can say like between US and the Russia, right? Uh, a space race was started, right? Both are developing new technology in the space, and we can say that was the first step in the development of GPS. Right? So in the Sputnik satellite, right? So when uh, the two physicists, John, Dr. William Buer and Dr. George Waffenbach, right? These two physicists, right? Scientists at John Hopkins uh, University. So they have observed the like this satellite is broadcasting the radio signals, right? So they have discovered that they could accurately calculate their location, the satellite location in their orbit uh, through the Doppler effect, right? So this is some one principle, the Doppler effect. Maybe you have heard about this principle in your some school physics, right? So this effect is like satellites which are in the orbit, uh, when it will closer to the point of observation, right? Then the frequency of the its signals, its increase and decrease as it moves near or far, right? So as the satellite is moving in the orbit and you will set a observation point, then the frequency of the signal, right, it will increase or decrease as the satellite will move. So from that thing we can find the position of satellite from your observation point, right, in the orbit. So so these two scientists means discover the way like how we can calculate the location in the orbit through the Doppler effect. So from that the question was raised like, if we can find the position of satellite in this orbit, then is it possible to find like some location on the earth from satellite, right? So uh, from this question or from this curiosity, right, it will lead to the development of GPS precursor, right? So it's called a transit, right? So transit is it's kind of GPS. Actually, right now its name is GPS, but when the project was started to find the location on the Earth, right? The project or the technology they've given the name the transit, right? So this transit was first tested in 1960 and it was fully operated in 1964. So these transits, this in this technology, right? It will use this 5 satellite constellation, right? As the GPS nowadays using 24 satellite, right? So similar to that, the transit was using 5 satellites, right? And uh, this transit is mainly developed for the US Navy and their submarine armed with the uh, ballistic missiles, right? So as I told, the, this, uh, initially the main application or for the application of in the military for the missiles guidance system, GPS means develop the scientists have started the technology GPS, right? They and so that's why here the actually at, at that time the name was transit, right? uh, then this transit was not as accurate as the GPS, right? Because we know like the transit it was uh, technology about 1960s, right? 1960, 1970, and right now the we are in the 2020, right? So definitely day by day technology will improve. So the transit was not accurate, right? So this transit had the accuracy of 25 meters, right? So right, and nowadays the GP has the accuracy of 10 meters, right? And this transit was only able to give the location in the two dimension, right? And whatever the location is given by this transit, right? So that location is pinged after some few hours. Like in the GPS, you will get the whatever location we are tracking, right? So after interval of some second, you will get the updated location, right? So that way in transit, you get the updated location after some few hours, right? So these are the comparison between GPS and transit, right? But still, this transit has proved like the satellite constellation based navigation system was feasible, right? You can develop some technology, right, that can navigate, right, or we can use for navigation purpose, right? So the technology is feasible. uh, so not only the transit, but apart from that, other some program or some development like program 621B, then the SECOR, sequential collation of range, and the timation, timation satellites, right? So these three thing, right? Also, we can add in the development of or the history of the development of GPS, right? So, uh, so this program 62B, right? That was held in some 1962 to 1972, right? So this 10 year, right? So in that, it's a kind of a series confidential USF studies which allow for altitude to be measured via satellite, right? Uh, Nowadays we are measuring the latitude and longitude, right? But in that program, there it was a project, or we can say it's a program in that it's allowed to measure the altitude via satellite, right? And in that program, they have developed the prototype GPS receiver, right? So one kind of receiver they have developed. After that, uh, from 1964 to 1969, right? In that duration, the sequential collation of range SECO, right? It's satellite which were developed by the U.S. Army for geodetic surveying, right? So in that duration, uh, the U.S. Army, or we can say for U.S. purpose of U.S. Army, right? The satellites were developed, right? And its name is SECOR. And finally, in 1967, 1969, and 1974, right? In that time, specific satellites called Timation, right? So in that, the satellites launched the first atomic clock into the space for accurate timekeeping, right? So nowadays, all the GPS satellites, right? They are using the atomic clock for the timekeeping, right? So the time first atomic clock was launched in the some 1960s, 1990, 1969, and 1974. So in 1970s. So all these four, right? If you collaborate these four, right? So using these four, or whatever the technology used in this four program, right? So GPS was created by combining the best element of all these development, right? So in September 1973, right, and there was a meeting in that U.S. Department of Defense realized the potential of satellite-based navigation system, right? So they have discussed plan to develop a defense navigation satellite system, which is called DNSS, right? And this DNSS they want to develop for the all branch of the military, right? Means Navy, Air Force, and the paramilitary, right? Uh, so like the different branch have do not have to create their own, right? If they have the single system, then it's easy to maintain, right? So these DNSs, after some time of interval or after some year, it was renamed as a Nowstar, right? So Nowstar is a short form of the navigation system using timing and ranging, right? And nowadays we will call it as a Nowstar GPS. So in 1978, the first experimental GPS satellite was launched, right? And and from 1978 to 1985, right? Total some 10 satellites was launched, and those all satellites, it's they've given a series like Block 1 satellite, right? So uh, the first satellite of uh, this Block 1 satellite series, right? It was launched in 1978, and the main purpose of this satellite is purely for testing purpose, right? uh, and and the testing is like the experiment is about like, is it visible, this GPS concept is viable, right? It's possible or not, feasible or not, right? So for that, the satellite was launched, right? So you can see that picture, right? It's of the first satellite, right?
Sir, please allow Aman to enter the meeting. Sir, he is waiting out in
Okay,
lobby.
okay, fine. However, in 1983, before some new technology or some success came to the picture, right? Before that, one incidents was happened, like Korean Airlines flight 007 was shut down by a Russian, right? After it's mistakenly entered the prohibited airspace, right? So after these incidents, US President Ronald Reagan announced that GPS would be the available for the public, right, or wider public once the project was complete. Uh, so such kind of event will not happen, right? Such kind of accident will not happen. So the development of block 2, right? So the first series was block 1, and after that the new series was block 2, and that was began in 1983, right? And in that they have launched uh, some 9 satellites, right? So the 9 satellites were launched between this 1989 to 90, and this was the first operational GPS constellation, right? Uh, Also, like the Gulf War that was happened in 1991, right? And that is, maybe you heard about it, right? It's for oil price rising, right? So it's against some 35 countries, leading by US to the Iraq, right? So uh, in that war, right, the GPS was extensively used. Uh, in the following years, more Block 2 satellites, right? So the Block 2A during 1999 to 97 were launched, and by April 1995, GPS was declared fully operational capacity by the Air Force Space Command. However, the publicly available GPS was launched, right, by a policy called selective availability, right? And we have seen like this feature which degraded the signal quality for the civilian. And in in 2000, uh, May 2000, right, this feature was discontinued, right? However, the US still has the power to degrade or even shut down the GPS in the specific region, right? So this GPS, we can say like, right, we'll see in the policy and the governance, right? A lot of agencies with a lot of organization are involved in this GPS, right? To maintain the GPS, to decide the rules regulation for the GPS, right? But the head of the authority, right? It's still US. Currently, there are 12 block IIR, then, or block 2R, right? Uh, During the 1997 to 2004, and the 7 block 2 RM during 2005 to 2009, and the 12 block to I uh, to F, right? From 2010 to 2016, satellites power the GPS constellation, right? Uh, so implement to the GPS, and the new satellites continue, right, to be researched and developed, with the block 3A satellites currently being manufactured, and its first launch is scheduled in September 2018, right? And more advanced block 3F satellites are scheduled to start development in 2026, right? In the future, and it will means complete by 2034. So this is about the interesting history of GPS, right? Then we'll see the GPS governance, right? So this GPS governance is like how uh, the GPS is maintained, how means, there are rules to use the GPS. If some company, some organization want to use GPS, what are the rules? If some will develop the augmented system, right? Then what are the rules? So these all things are decided or controlled by the GPS governance, right? So it's provide the information about the US government, the stewardship of the GPS as a national asset that is integral to the US national security, economic growth, transportation safety, international leadership, and the homeland security, right? So in this GPS governance, we can include like policy and law, then the organization which are involved, right? Then how the program, right? In GPS, every day the scientists or the people are doing the research, right? Also, they will updated the technology, right? So also they maintain the that system, right? So they definitely need the fund money, right? So how they will raise the fund, who are giving those money, right? Then the international cooperation, like some countries are the part of that governance, right? So that we can include. Then at the last we can include like the spectrum and interference, right? So these, for GPS they are using the radio frequency signal, and those signal have the specific range of the frequency, right? So definitely those frequency should not be used by some other user or some other device, right? Otherwise what happens, the frequency will create the interference, right? It create the disturbance, like uh, in GPS, wherever they are sending the signal and the receiver side receiving the signal, right? If the same frequency signal is generated by some other user or some other device, then their signal can also be received, right? So because of that, whatever the signal is received or whatever we are interpreting, right, it may be wrong. So that kind of interference should not be there, right? So for that, these GPS governments are taking some step, right? In the spectrum, we know, like we have heard about the spectrum, right? In mobile also, for mobile network also, we are using radio frequency, right, signal. So those signal are fixed, like each the company, they have provide a band, right? So from this frequency to this frequency is used by this one. This frequency is from this to this frequency is used by this particular company, right? So maybe you have heard about that spectrum. Uh, um, when corruption, right, about like distribution of spectrum was not properly done by the government, right? The scams, spectrum scam, right? Some Raja, something, some kind of name was there, right? At that time, it was the authority. So that we will include in this GPS governance, right? So let's see one by one. So policy and law. So since 1980, multiple U.S. presidents have issued the consistent policy, right? And the Congress has enacted elements of this policy as the permanent law, right? So every year or every time, right? But whenever they need to change the policy, right? Generally, that policy is given by the U.S. president. Then the organization we can like in the GPS governance, some organization like National Executive Committee, the National Coordination Office, Advisory Board, and the Civil GPS Service Interface Committee, right? So these four are included in the organization, or this organization are, we can say, the part of this governance, right? So this National Executive Committee, the GPS program, receives the national level attention and guidance from the joint civil and military body called the National Executive Committee for Space-Based Positioning, Navigation, and the Timing. Right? So this positioning, navigation, timing is known as a PNT. So this term space-based PNT refer to the GPS, GPS augmentations, and the GPS and the other global navigation satellite system. Right? So this committee is part of it. Then the National Coordination Office, NCO, right? So the NCO is the permanent staff of the NEC, right? National Executive Committee for the space-based PNT. It is responsible for collecting GPS-related information from multiple federal agencies to support the operation of NEC, including interagency coordination, concession development, and issue resolution. Right? So these different committee, different office have the different function or different role. Then if you talk about the advisory board, so it's provide the independent advice to the U.S. government on GPS related policy, planning, program management, and the funding profiles in the relation to the current state of the national and the international satellite navigation service. Right? Then the Civil GPS Service Interface Committee, right? So this is called CGSIC, right? It's a recognized worldwide forum for effective interaction between all civil GPS user and the US GPS authority, right? So this committee has the work like it is the bridge between the civil GPS user and the authority, right? The US Coast Guard Navigation Center, right? It coordinates and manages this CGSIC in the cooperation with the Department of Transportation. So these are some brief information, right? If you will search on the Google about GPS governance, you will get a lot of document, right, in the detail. And then we can include the federal agency, so numerous departments and agencies of US government participate in the operation management and the use of GPS as a national asset, right? So you can see like some it's kind of government agencies, right? Like Department of Defense, the Department of Transportation, Department of State, Department of Commerce, Department of Agriculture, Department of Interior, Department of Homeland Security, uh, Joint Chiefs of Staff, then NASA, right? So these are some examples. Apart from these, numerous departments are involved. Then in international organizations, so it is about like US efforts related to the GPS cooperation with the other countries, right? Like Australia, China, Europe, India, Japan, Korea, Russia, UK, etc. Right? and the international organization or some organization from the different countries. The National Space Policy of 2020, right, encourages international cooperation related to the GPS and the global navigation system, right, satellite system, which is called GNSS. Okay. Uh, so these are related to the organization, then the program funding, right? So as I told, like to maintain all those things, you need the fund, right? So the American taxpayer pays for the GPS service enjoyed throughout the world. All GPS program funding comes from the general US tax revenues. The bulk of the program is budgeted through the Department of Defense, which has the primary responsibility for developing, operating, sustaining, modernizing the GPS, right? So generally, the main authority of uh, the modernization of GPS is the Department of Defense, right? So they are provide the fund for the such kind of modernization or upgradation. Uh, then the Department of Transportation, right? The U.S. policy assigned this Department of Transportation responsibility for funding the extra cost which is associated with the new civilian GPS upgrades, right? So Department of Transport also provide the fund. Uh, Agencies which unique requirement for the GPS are responsible for the funding them, right? So some company, right, they will want to use some specific unique requirement, then they will provide the fund for that. So we can say like in 2020, so last year, right? So the GPS program, the overall GPS program was funded, right, about some 1.71 billion dollar. So every year this budget is changed, depends on the GPS different program. Beyond this core GPS program, right, several federal agencies fund and manage the augmented system that improves the GPS performance in support of their particular needs. It is about the funding, then the spectrum interference. So the GPS, as I told, use the radio signals which have the different frequency, right? So we call it as a spectrum. The range of the frequency is known as a spectrum. So it's reserved for the radio navigation service, right? Ensuring that ensuring the continuity of the GPS service requires the protection uh, of the spectrum for from the interference. Interference means disturbance from the other signal. So the GPS interference can come from the variety of source, right? So this disturbance can rise from the variety of source, right? So in that sources we can include the radio emissions in nearby bands, right? Nearby band is like, for example, in GPS we are using some 50 megahertz frequency. Then in some other application you are using some 51 megahertz frequency, right? You have the difference of the frequency of 1 megahertz only, so you can consider as a nearby band, right? So because of those signal there is interference can rise. Then intentional or unintentional jamming, right? So jamming is like to block the frequency, right? You have heard about like whenever some confidential meeting was going on is going on, or like sometimes our prime minister will visit at some places. At that places they will they always they have the mobile jammer, right? So at that place your mobile will not work, right? So this kind of frequency jammer, right, it can be intentionally or it can be unintentionally, right? So that can create the interference. And so naturally occurring space weather, right? So because of the space weather also interference can happen. So the GPS jamming, so the FCC is clamping down on the marketing, sales, and use of the illegal cell phone and GPS jamming device. Right, uh, the consumers cannot legally use the signal jammers within the U.S. United States, U.S. Right. Then the adjacent band compatibility. The executive branch has established the power limit criteria for transmitters in the bands near to GPS, right? And which will ensure any future use of those bands will not disturb the GPS application, right? So they have divided the spectrum. They have given the frequency band to the application such a way that like uh, the nearby band of the GPS frequency, right, will not disturb the GPS application, right? So that way they have divided the spectrum. Use of foreign RNS signal. So the FCC rules require authorization of receive only Earth station operating with the non-US license radio navigation satellite service RNS satellites, right? So these are the some points related to the spectrum and the interference, right? So that is also uh, taken care by the GPS governance, right? Okay. This is about GPS governance. Now let's see the GPS policy, right, in the detail. So since 1980s, the multiple US presidents have issued the concessions policy encouraging the worldwide use of GPS for peaceful purpose, right? For use of the GPS for the positiveness, or we can say like some good purposes, right? The Congress has enacted the element of this policy, and they will make those those point as a permanent law. Uh, the stability and the transparency of the US policy combined with a long track record of dependent GPS service, right, have laid a solid foundation for the investment and the innovation in the GPS technology, right? So this policy is such a way like, right, uh, the GPS will get the investment like funding, and also uh, innovation can happen in this technology, right? So those policies they have made such a way. As a result, the commercial use of GPS technology has increased, right? Uh, so today we can experience that different application, many application or many companies are using the GPS, right? So because of this policy, right, that that it can possible. Uh, So the US space-based positioning, navigation, and timing policy of 2021, right, and that was signed by the US President Trump, and it established the goal to maintain the US leadership in the service provision and the responsible use of the global navigation satellite system, including GPS and the foreign system. Right? So that was the goal. Uh, so the government achieves this goal in the number of way, right? So in that they will include the free access for civilian use, uh, the management of GPS as a national asset, joint program funding, GPS modernization, international cooperation, right? Denying hostile use and spectrum protection, right? So this some of these we already seen in the GPS governance, right? So in specifically GPS policy, they will include the point related to this thing. Right? So let's see one by one. Use. Uh, so US government provides civilian access to GPS on the continuous worldwide basis, right? And that is free of the direct user fees, right? So it's kind of a free service. It also provides open free access to the information needed to develop the GPS user equipment, right? So if you want to do some research in that also, they will provide the free access to some information, right, of GPS equipment. Management of GPS is a national asset. So the GPS program receives the national level attention and guidance through the joint civilian military body established by the presidential directive, right? So they will give the GPS that much of importance, right? kind of national asset. Joint program funding, so that we have discussed, right? So the bulk of the GPS program is budgeted through the Department of Defense, right? And the Department of Transportation also contribute funding, right, to support the civilian GPS requirement, right? So these two departments mostly provide the fund, right? Apart from that, if some company needs some additional facility or some additional features, right, so they can also provide the fund, right? GPS modernization, so we know like every day the technology is improving, right? So to meet the growing demands and the stay competitive internationally, the US government is committed to long-term modernization program that will improve the GPS performance, right, including more robust resistance to interference, right? Then international cooperation, so the US engages with the other global navigation satellite system, provides to ensure the compatibility and encourage the interoperability with the like-minded nations. And it will promote the transparency in the civil service provision and enable the market access for US industry. Then the denying hostile use, so it is US policy to prevent the hostile use of GPS through the localized Daniel, right? So military jamming that does not only disturb the civil and the commercial GPS access outside the battlefield. And the US no longer use the, the selective ability to degrade the civil GPS accuracy, right? It's kind of like the military jamming for that purpose, or you can say like in the war, right? They are not they have not policy to provide to use GPS. And the spectrum protection, so the government works on the minimize the human sources of GPS interference through the spectrum regularization, right? And the interference detection and the mitigation effort and the law enforcement, right? So it's about how we can reduce the, or how we cannot create, how we will not uh, use this frequency or the spectrum, like it will create the interference to the GPS, right? So for that we will provide the spectrum protection. Okay, so there's for today, right? So today we'll finish the second unit and this GPS portion, right? Anybody have any doubt? Hello.